The moon is one of the most important things in our solar system, and yet sometimes it doesn't get the credit it deserves in terms of its effects. Nor do a lot of people know about its true origins. Join us as we explore the birth of the moon and how it affects our planet. So where shall we begin? How about we talk about the stats of the moon? As you'll see, the moon is much more impressive than you might think. For example, how big is the moon in terms of its diameter? The answer to that is 2,159 miles across, which means that the moon is bigger than Pluto. And also, it's the fifth largest moon in our solar system, which is impressive given all the moons of Jupiter, Saturn, etc. But it's also impressive that this means the ratio in terms of size between the moon to the Earth is a mere 1:4. No other planet has that small of a ratio in regards to the relation of a moon and planet, except technically Pluto, but few people count that as a planet anymore. Now you might think, well, why does a ratio matter? Does it really mean anything that it's a certain size compared to the Earth? Why yes, it does matter. Because the bigger the object is, the more force it has to exert, or in this case, the more gravity it has to exert. The reason the moon is so important is due in part to its size. If it were much bigger or much smaller, the Earth would literally not be the same. Yet what might be the most curious thing about it is that we still don't know a lot about the moon in regards to certain elements. We have guesses, we have theories, and of course we have samples, but there are some facts that are not fully proven yet. For example, where did the moon come from exactly? The formation of the universe is by and large one of the biggest and most important mysteries in all of the world today. There are many explanations for what could have happened or even what might have happened, but do we know what happened? No, we don't, and that brings us to the moon. Because obviously the moon is out there and obviously it has a big impact on our planet, but how it got up there so close and yet far enough to help us is still a bit of a pickle to discern. As of right now, there is one major theory that most scientists feel is the right answer in regards to the moon's birth. It's called the giant impact theory. To put it basically, when the solar system was being formed, a bunch of celestial objects were being made. You know, planets, moons, asteroids, comets, that kind of thing. But unlike the solar system we have right now, not everything was tethered down just yet, which means a lot of pieces were sent flying into the vast reaches of space. One of these bodies is believed to have been about the size of Mars, and it got thrown into or just plain collided with the Earth. When the young Earth and this rogue body collided, the energy involved was 100 million times larger than the much later event that believed to have wiped out the dinosaurs. Despite the impressive explosive yield that this impact would have brought, it didn't wipe out the Earth, far from it. It merely jettisoned some parts of the Earth back into space. But because of the Earth's gravity, they stayed relatively close to one another. So after another couple million years, the moon was formed, and it eventually became locked to the Earth as we now know it. And there are many who believe this for very basic reasons, one of which is that after we went to the moon via the Apollo missions and got a bunch of moon rocks, we found out that the composition of the moon and the Earth are very similar. Incredibly similar, in fact. Now sure, there are other logical explanations for this, including that the stuff that made the Earth and Moon were formed from the same pool of rocks, and so on and so forth. Many think, though, that the near-identical natures of some of the elements prove that the Moon came from the Earth, which would give us an even greater connection to it than we had before. But there are also people who believe that because of certain differences on the Moon, that the impact theory isn't exactly fully explained. In terms of composition, the Earth and Moon are almost twins, their compositions differing by at most a few parts in a million. Alessandra Mastrobono Battisi, an astrophysicist at the Israel Institute of Technology in Haifa, told Space.com. This contradiction has cast a long shadow on the giant impact model. So what are the other theories? Well, one is a bit like one I just mentioned about Earth and the Moon coming from the same pile of rocks. But it's not quite as simple as that, for in 2012 a group of NASA scientists proposed that maybe the Earth and the Moon were formed when two massive bodies collided with each other, and that wreckage formed both the Earth and the Moon at the same time. After colliding, the two similar-sized bodies then recollided, forming an early Earth surrounded by a disk of material that combined to form the moon, NASA said. The recollision and subsequent merger left the two bodies with the similar chemical compositions seen today. And believe it or not, there are even more theories to how the moon got to where it is right now, such as the moon already being created in the solar system and the Earth just caught it in its gravity, or that the moon was actually part of Venus for a time, but then for one reason or another the Earth grabbed onto it, and because the Earth has a more powerful gravity than Venus, it siphoned it away from it, which would explain why Venus has no moons. As with all theories regarding the creation of something, it's all speculation. There's no true way of knowing what really happened at the beginning of the solar system. And by that extension, while many of these theories do have scientific basis, or can be proved to be plausible in one form or another, they don't answer everything. No one theory can answer everything that needs to be explained about the moon's creation, which isn't exactly a bad thing, because it means that people have something to look for and try to discern. And if we were able to figure out the truth about the moon, it could give us another big clue as to why the solar system turned out like it did. But let's focus back on the moon solely for a bit, okay? One of the most asked questions about the moon isn't just about its formation. It's about why the moon is where it is position-wise, meaning why is it exactly 238,900 miles away from the Earth? Why not closer? Why not farther away? Why is it exactly there? The answer is push and pull. More accurately, the push and pull of the gravity fields of both the moon and Earth. You see, because of how the Earth and the moon are size-wise, they exert a certain amount of gravity. This is part of the reason we were able to go to the moon multiple times, because we could orbit the moon via its own gravity and thus wander around it, land on it, and then get back up to the ship in question. When two bodies have massive gravity fields, they push and pull against one another, then try and find the balance between just far enough, yet just close enough to where they don't cause the other too much trouble. After all, if the moon didn't have a large gravity of its own, it would have either floated away or been like a massive asteroid and just crashed into the Earth. Over the course of many years, the moon fell into the position we have it in right now, where the push and pull are slight enough to still happen but not cause massive movements. However, there is a catch to this. You see, the push and pull are still happening, even now, millions of years later, and that's causing a bit of a curious effect on the moon. Mainly, every single year the moon moves a few centimeters more away from the Earth, which isn't bad in context because a centimeter is really small. But eventually, that'll become an inch away, and then a foot away, then a meter, and on until eventually it goes out of reach of the Earth. To be clear, this won't happen for a long period of time, but it is going to happen, which should make us all the more grateful that we have the moon like it is right now. So let's talk about the moon's effects on the Earth itself. There are many things that the moon does for the Earth, even if you don't realize it. The obvious one is that it helps light up the night. Due to the rotation of the Earth, the sun is not visible to half the planet for about 12 hours. When that happens, you'd think that the Earth would be very dark, except that the moon's surface is reflective. So the light that is still reaching the moon is reflecting off the surface, and thus we have a giant ball of space rock in the sky to look at. If you're wondering why we see the moon in phases, that has to do with the positions of the Earth, moon, and sun respectively. As noted, the moon reflects the light given to it by the sun, but because of the positions of all three bodies, the light doesn't always reach all of the moon. So if the light doesn't reach, only part of the moon gets lit up, as it were. Not that it matters, to be honest, the sky wouldn't be totally black, and since the invention of electricity, we technically don't need the moon or the stars to see at night. But it's still a nice thing to see on a clear night where nothing is blocking your view. Oh, and if you're wondering why we only see one side of the moon, it's not because the moon is tidally locked, rather it's because it takes over 27.3 days to do a full rotation. So when you add that to how the Earth moves every 24 hours, and the fact that it also takes 27 days to fully rotate the Earth, and you only get to see one side of the moon. Yeah, the Earth moves much faster than the moon. Bet you thought it was the other way around, huh? Keeping it going with its effects, arguably the biggest effect that the moon exerts on Earth is its control of the tides. The The moon helps cause the tides of the ocean to grow or recede depending on its position. And yes, that's because of the gravity it exerts. The ground beneath your feet is stable, and the Earth's own gravity is holding that firm. But the water? Well, that's another story, and one that is constantly disrupted by the moon itself. That's why at times during full moons or new moons, the oceans will either act really violently or really calm. It just depends on the day and what is going on with the moon. There is even an event that goes on in the oceans known as the supermoon, which is the literal closest point to which the Earth is next to the moon. Because the moon is closer than normal, the oceans act appropriate. If the moon were to suddenly get a lot closer to the Earth, the oceans would act so violently that tidal waves or tsunamis would likely occur. If you've seen the movie Bruce Almighty, that is an accurate representation of what would happen. Of course, this also raises the question of what would happen if the moon suddenly vanished. How would everything be affected? A lot in some ways, but not a lot in others. Sticking with the oceans and seas, without the moon's gravitational pull, the tides would change, maybe not overly noticeably over the course of a few years, but its pull would be missed for some. The sun would balance that out though. However, it missing from the sky would affect a lot of animals. Animals are smarter than you give them credit for, and creatures like moths not only recognize the moon, but they use it as a guide for them to get around and do certain activities. And other animals just plain rely on the moon to light up their home areas and help get them around. As for humanity, we'd face a much more dangerous problem. Remember what I said about the push and pull of the Earth and moon gravities? That effect didn't just hold the moon in orbit, it helped keep the Earth in position. Specifically, its tilted position, the tilt to which we experience the seasons like we do. If that's gone, then the seasons are going to shift via the Earth wobbling. Everything we know about the seasons would be completely out of whack, said Paul Suter, astrophysicist at the Flatiron Institute. At a certain angle, some places on the planet would hardly ever see the sun at all, and at others, the sun would be overhead for months on end, which would mean life on Earth in general would shift dramatically, and that we'd be living on a much different world than the one we have now, and some heavy adaptations would need to be done. But since the moon is fine, and barring a weird collision or us blowing it up, which has been proposed in the past, believe it or not, the moon will remain where it is, and for that, we should be grateful. Thanks for watching, everyone. What did you think of these facts about the moon and its origins? Are you surprised by how much the moon affects us? Are you curious too as to where it came from? Let me know in the comments below. Be sure to subscribe, and I'll see you next time on the channel.